For this question, they say that the function f is defined for all real values of x by fx equals to 1 over h inverse x minus 1, where hx is equals to ln x, and we have a condition here, it says x is more than 1. So for the first questions, A, find the function of composite h, composite with h. So in order to find out the function of f first, we have to find out what is our h inverse. So therefore, start with finding h inverse. We're using composite method, h inverse x equals to x. So substitute this h inverse into the function of h. So this x will be replaced by h inverse. It will become ln h inverse x equals to x. So when you want to unlock that ln, it will become e to the power of x. And then when we want to find our function, it will be equals to fx equals to 1 over ex minus 1. So in other words, when we simplify, it will be e negative x minus 1. Then we can proceed finding our composite function f hx. So hx is ln x. When we substitute into the function of f, so it will be replaced by the position of x here. And then when you want to simplify, bear in mind, e ln, if we have a coefficient here, we cannot cancel. So we need to move this negative using properties of logarithm. So it will be back to the x power of negative 1. Then only the e ln can be cancelled. So in this case, remaining part is x power of negative 1, which is 1 over x minus 1. Then when we move to the part B, sketch the graph of this function. So as we know, this function is generated from h inverse. So h inverse is generated from hx, and this hx is not a general function that have a condition say that it only accepts for x more than 1. So we have to draw the graph step by step, generate one by one. So starting from hx, when we're having the graph of the log x, ln x, so supposedly asymptote happen at x equals to 0, and then it will be going up like that, intercept is 1. So since the condition is said more than equal 1, so the graph here only, the domain here state that they only want this side. So the rest of it, this one is not involved. So when we change it to h inverse, so how to get h inverse? We need to refract through y equals to x. So originally from x equals to 1 shoot up. So when we refract, it will go into y-axis with x equals to 1 here. So this is our hx, this is our h inverse. So when we're getting h inverse, means we are just drawing ex. What we need to draw for this function is e negative x minus 1. So we move it one by one. So to get the function of e negative x, start from ex. So ex is this part. When you want to get e negative x, when we multiply a coefficient negative x here means it will having refraction throughout the y-axis. So this negative x and this x, when we want to compare the graph, ex and e negative x is refraction along the y-axis. So when we doing refraction along the y-axis, here we come e negative x, and then our function here is minus 1. So the whole function minus 1 means the whole function will be moving down 1 unit. So that's why our curve will be touching origin. So in order to draw this graph correctly, our final result it will be start with 0, then shooting up to the left. So this is our function of fx. Then this is y, this is x, and we are touching 0. Then when we move to question C, finding f inverse. To finding f inverse, we're using composite method, f inverse equals to x. So we're going to substitute f inverse into the function of x here. So it will be e negative f inverse minus 1 equals to x. We try to simplify. Move the negative 1, it will be plus 1. And then when we move the exponential, it will be ln for x plus 1, where you can put modulus or you can put bracket also can to make sure the function defined. Then move the negative, just negative ln x plus 1. Then when we want to answer the question of domain and range, so domain of the f inverse, it will be going to refer to the range of the function. So our function starting with condition statement here, it make our function is not in general piece. So it just involve one part of it. So therefore, when we finding domain and range for this fx, we can't just memorize as general. So we have to find back from its origin, and based on the graph, we read out the domain and range. So as the range of this function will be start from 0 up to infinity, where 0 is your minimum point, so 0 is included. So wait a minute, is it 0 included? So you have to identify out. Start from 1. 1 is not included. So when we refract to the fh inverse, is not included. So when we transform to e negative x, is not included. So supposedly this point is not included. So 0 is not included up to infinity. Then when we want to find the range of f inverse, then we refer to the domain of function. So look at the domain means look at the left right here. So it will be negative infinity come to 0. Also not included in this point.